Welcome to lesson number 7, where we're going to be looking at order of transformations and combining transformations. In general, the order doesn't matter, except for, if we look at this note here, we're doing a translation and a stretch in the same direction, or along the same axis in the same direction, or when we're doing a reflection and translation in combination. Now, a good rule of thumb is just to always do your stretches first, and then your reflections, and then finally finish off with a translation. Now we're going to jump in looking at class example number 1, where I have the relation A and B. And so what we want to determine is what transformations were made in order to go from A to B, from A to B. So the first thing I notice is that A opens up to the left, whereas B opens up to the right. So what this means is there's been a reflection and that reflection is in the y-axis. Second, there's been a translation, and it looks like a vertical translation. So a vertical translation, and that is, let's see, 1, 2, 3 units up. And also a horizontal translation, like if you look at my my lowest value on the x here, there's also horizontal translation. And that looks like 2 units left. Let's look at class example number 2. We're going to describe the series of transformations that were made to go from A to B. So here's A and here's B. First thing that we can see is that figure A compared to B is a lot shorter, which means that there's been a horizontal stretch. Now, if you look at the horizontal stretch, this is 4 units long, whereas this one is 1, 2, 3, 4, 5, 6, 7, 8 units long. And so what that means is there's been a horizontal stretch along the y-axis. So by a factor of 2. And we've also, if we take A, we've moved it, so it looks like the center moves to 4. So there's also a horizontal translation, 4 units left. And we've also moved our center 7 units down. And a vertical translation, 7 units down. From graph A to C, so if we look at what's gone on from here to here, it's kind of similar. We've increased by a factor of 2 vertically this time. So we have a vertical stretch, and that's along the x-axis. So this is by a factor of 2. And we've also moved up and over here, and so let's look at our horizontal translation. So we have a translation from 5 to 6 units. So horizontal translation, 6 units left. And we've moved 4 units up, it appears. So vertical translation, 4 units up. Now, class example 3, we want to describe the transformations are applied to the graph of the function when the following changes are made to its equation. We want to know if the order matters when these transformations are performed after the final graph. So first of all, if we replace x with 3x and y with y plus 4, we want to talk about what changes are made. So first of all, we would have a horizontal stretch, along the y-axis. And this is, if my x is getting replaced with 3x, this is by a factor of 1/3. And then y is replaced with y plus 4. And so we also have a vertical translation 4 units down. Now we want to put these into our graph, and so let's see if the order matters for y going to f of x. So if y is equal to f of x, we could either replace x with 3x first, or we could replace y with y plus 4 first. So let's first replace, let's do it in the order that it's written. So y is equal to f of 3x. And then we would have y plus 4, which we would bring to the other side. So y 3x minus 4. Now let's see if it matters the other way, where we start again with y is equal to f of x, and then we would have y is equal to f of x minus 4, and then finally y is equal to f of 3x minus 4. So in this case, the order did not matter. Order did not matter. Now this one might be a different story. So first of all, if I replace x with 2/3 x, this is going to be a horizontal stretch. So by a factor of 3/2. We also have a vertical stretch. So we have a vertical stretch, and this is by a factor of 1/3. If we replace y with just 3y, a factor of 1/3. We also have a reflection in the x-axis. And finally, we have a horizontal translation, 2 units to the left. Now let's see what happens when we plug these changes in. And so first of all, our starting equation was y is equal to f of x. Now, if I do this in order of my translations written up top and my transformations written up top, then my next transformation is going to look like this: 2/3 x, followed by my vertical stretch. And then finally, I'm going to make this substitution with x plus 2. Next, I'm going to insert my transformations backwards. So first I'll do x plus 2, and then I'll do my reflection vertical stretch, followed by my horizontal stretch. So first of all, I have y is equal to f of x, which if I do it backwards, would then be y is equal to f of x plus 2, followed by my vertical stretch. So y is equal to, and I'll go negative, I should have put that negative in there, negative 1/3, and that negative goes there as well, negative 1/3 f of x plus 2, and then followed by my horizontal stretch. So I'll do it right here. Y is equal to negative 1/3 f of 2/3 x plus 2. Now this, although it looks very similar, is different, because here it looks as if this 2/3 has been factored out, which if I were to bring it back in, we would still have 2/3 x, but instead of saying plus 2, this would be 2/3 x plus 4/3. And so this is going to be different than this answer here, which means that the order does matter. Next, let's look at the parabola y is equal to x squared plus 1, and the following transformations are applied in the order shown. So first of all, we're gonna do a horizontal translation 2 units to the left. And so all my points are going to move over to the left by 2 points, and I'm just going to be moving 3 points at a time. And so my next line is going to look something like this. So the next thing I'm going to do is a reflection in the x-axis. So here's my x-axis. All my points are going to be inverted. And so this will go down here, and this will go down here, and my next point looks something like this. Next, we have a vertical stretch about the about the x-axis by a factor of 0.5. This means that we're going to be taking all my y values and multiplying them by 0.5. So this value will move up here, and then these values at -5 will move up to -2.5. And now my graph looks something like this. And last, we have a vertical translation 3 units down. And so we're going to take all these values and move them down 3 units. 1, 2, 3. And then 1, 1, 2, 3. And 1, 2, 3. And so my new graph is going to look something like this.